Today is 4th November 2020. We'll be starting with our next module that is related to knowledge in uncertain domain. So, uncertainty is a key concept in understanding how do you acquire knowledge, represent knowledge, and infer through the knowledge when there is uncertainty in the domain of a respective problem. We already have seen that if there is uncertainty about the actions of an agent, or there is uncertainty about the environment being deterministic or being dynamic or not, in those scenarios we have to execute the plan, the lines of action using some contingencies, and contingency is a way to compensate the uncertainty in the environment of the problem. In this case, what we do is we do not change the way the problem is defined. We do not change the way the application of solution finding is done, maybe using search, maybe using knowledge based agent, maybe using some other kind of AI mechanism. So essentially what we do is we do extra work in designing alternative plans of actions so that the uncertainty can be compensated online whenever we are realizing the plan. But this mechanism may not be assuring you best possible alternative and may not be actually giving you the exact amount of rationalism that is expected through an AI agent. And hence, we need to learn how we can handle uncertainty in some other way in which the knowledge representation itself compensates by representing the information in the world in a way that it is catering the uncertainties in the environment. So to begin with this chapter, we will be talking about what do you mean by uncertainty, how does the probability theory represents the uncertainty in certain ways. Then we'll be talking about syntax and semantics of the uh, knowledge representation that uses probability theory and uncertainty or utility theory for decision making. So the syntax and semantics for the knowledge representation that uses probability theory and utility theory in order to design a decision process or decision making process. So ultimately, because the any sort of AI agent, it is decision making what the agent does. Will I do one of the set of actions or not? So this decision making is a very important key characteristic of any of the agents that we have seen so far. And thus, the probability theory with utility theory helps us gain that understanding, gain that representation, which will enabled to do take the proper decision in order that the agent that we have designed is a rational agent. Such an agent that combines utility as well as probability theory is called as utility agent, okay, or decision theoretic agent, and we will shortly see how that agent is measured. Once we know how we represent the uncertainty using probability and utility theory in syntax and semantics representation, then the next level of things would be how we infer certain kind of unknowns so that we can take decisions. And this inference technique or inference is nothing but mechanism of finding out unknown based on knowns. And then when I have an inference procedure defined for uncertain domain, that can easily be used for designing and giving out a solution for problems which are having uncertain domains in a right way using the agent abstraction. Now, the first thing in this chapter, we will be talking about what do you mean by independence of multiple events? What do you mean by Bayes rule? How does Bayes rule supports in order that we can determine the probability of a future event based on some facts that we know which are conditioned on certain current events. Uh, excuse me. Now we'll start begin understanding the concept of uncertainty and how does creeps into the work of the agents that we are going to design. Now, there is a at this particular to explain this instance, we are going to consider the example of reaching the airport at a particular time. So, there is an action AT. Okay, this T is the suffix. This action is defined as leave for the airport at T minutes before the flight. So flight, if it is scheduled, let's say 9 o'clock in Delhi, we may decide to leave at 7 o'clock, which is 2 hours before. So 2 hours means 120 minutes. So A120 would be the action. So there could be different actions. One is to get to the airport in order to reach to a destination of A120. Okay, so this is a big problem that we don't understand in my decision making process. So decision is very simple: whether to when to leave for the airport so that I can reach the flight which is pre-scheduled one. Okay, now going ahead, what all problems I can face in achieving or taking this particular decision? Number one is I have in this particular scenario partial observability in the task environment. That is, there are many things that I'm unaware sitting at home and deciding to take a cab or take a maybe some other modality in order to reach the airport. And those uncertainties, which those things which are not observable, I'm currently uncertain about their actual state. So I don't know whether the roads are clean or roads have a lot of roadblocks, whether the traffic is there on the roads or not. What does the traffic actually is today? I may have certain traffic projections that on a particular time in the day, the road to the airport has this much traffic. But I don't know what is the scenario. So I'm working on this, and that's why if I want to take a decision कि कितने जल्दी निकलना चाहिए, that decision is fairly based on some predictions which are not certain. Okay, we are not certain. And the thing is, I'm aware that I may be aware about the current traffic situation due to some sort of a high-tech city traffic planning system, which I just go and watch and know that okay, this is the uh, sorry, this is the road which is blocked, and this is the road which is not blocked, and there are multiple roads to reach my destination. But I may not be aware how many other passengers or how many other people are taking the same route to the airport, because there may be multiple flights scheduled at the same time, or maybe before or after my plane, and there may be a lot of other people's also taking involved in taking the same decision that I am taking when to leave from the home. So we are not sure about how these other players are going to play their role in, and this is again another point of, or another way in which uncertainty can creep in, and my decision that I'm taking will depend on how much good I am at predicting this uncertain behavior. So the next thing is, say suppose I'm actually controlling the partial observability somehow, okay, maybe using some sort of a guess, some sort of a loose theme, but I may have noisy sensors. That is, the traffic reports that I'm receiving, they may be from some people who are not that much keen in providing the reports in timely manner. I may have a report that a particular road is blocked, but that particular news is running since morning, and they are not. We are not sure about whether that is the current status or what would be the future status. They're not aware of okay, what exactly is the authorities doing for that roadblock to get over, or maybe again these sort of noisy sensors or sensors through which I sense the traffic, the news channels or maybe the broadcasters, they're not providing me the right kind of information at the right time. This may be about some weather forecasting agencies as well, and we are aware of it. It happens in India a lot of times. Now, the next thing that we need to understand is the sometimes it happens that uncertainty is in the actual outcome. That is, when I'm traveling, I may have decided to board a taxi at say 2 hours prior to my plane, and I know that getting to the airport is around 1.5 hours. So I have half an hour, what you can say, early going to the airport. But it may happen that in the process of moving to the airport, suddenly I lose me with my taxi. There is certain things like it breaks down due to some failure, like a tire getting flat, or maybe a wiring disruption, or maybe something to do with the action that the agent is performing. So this particular type of uncertainty is due to whatever decisions you are making are based on what gives you what outcomes. Whether if the action itself is not certain, means that the action is going to give you not always the exact outcome that you are expecting. In those scenarios, again, uncertainty creeps into the decision making process. uh, Maybe you may think that uncertainty is always due to uncertain behaviors of the sensors, uncertain behaviors of the actuator, uncertain behavior of the observability of the environment. But that's not the only case, because of certain laziness in the overall system. In order to compensate or get all the requisite parameters in order to understand the state of environment, I may be in a position which is, I may refer to be as uncertain. Okay, just a information, just an example about it is, say suppose I went to a dentist and I asked, and I'm, because of say pain in my teeth, I'm going over there. Can he be certain that by looking at me, can he be certain that I will be having a cavity in my teeth, and because of that cavity this pain is arisen? And if you closely think about it, in medical diagnosis domain, there is always set of symptoms that you get from the history of the patient by talking to a patient and getting information from the patient, and using that information you try to predict what could be the cause and effect relationship, and based on that cause and effect relationship you diagnose him. So in medical diagnosis, there could be multiple overlaps between multiple disease and their causes. So I may have cause of getting pain due to not necessarily cavity, but maybe something stuck up in my teeth, or maybe my gum has certain gum disease. So there could be multiple reasons in which same symptom can appear, and due to that I have to circumvent the other possibilities. I have to get more and more information from the patient, whether he has a previous occasion where he had a gum disease or not, whether that is the first time he is having the that particular pain in the teeth, etc., etc. So there are a lot of extra information that is required, which may not be what the dentist or the agent here has time for getting in the first go. So he may actually base his decision on some unknown, some known facts and certain things which he may speculate about, and this speculation about, due to the laziness of the agent, which is not particularly for the observability, due to observability of the environment. And there comes the sense of uncertainty again into the modeling of the decision making process. Now the fourth point here, as the problem that causes the uncertainty to appear, says that there could be immense complexity of modeling and predicting traffic, and due to this immense complexity there could be numerous variables that can contribute towards the modeling of a traffic pattern, and I may not be the responsible system which is predicting the traffic may not be able to capture all the variables that are necessary to predict the traffic with a certain degree of conformance, and due to that uncertainty can creep into the decision making process. And please understand, why we are talking about decision making today is, decision making is